Hello everyone and welcome to Algebra 1 Honors. This is lesson 8-3. It's a very important lesson because it's a lesson on slope. Before we start, what exactly is a slope? Okay, just basically a slope is the steepness or lack of steepness that a hill or an incline has. For example, let's look over here at these two planes. Over on this side we have a plane that has taken off and it goes 100 meters and it rises 15 meters. Okay, well, what does this have to do with slope? Well, what we want to do is we want to find out basically how steep is this incline. And to do this, we have to use the slope. And the slope is basically, and let's write this down, the slope is or equals the rise over the run. What does that mean? Well, in the case of this airplane, the run is how far it travels along the ground, how far it was going to travel in a horizontal direction. And the rise is how high this airplane is going to climb in this time it takes it to go 100 meters. It is the vertical distance. So if I was going to calculate the slope of this airplane, I would say, well, the rise, how high does it come up, is 15 meters. Okay, I would say it's 15. And the run is 100. Now this is the slope, but slopes are always reduced. Okay, we don't leave it like that. We reduce it. And you can see that we can reduce it by 5. Okay, so if I reduce it, I will have 3 over 20. So the slope for this particular example is 3 over 20. And another name for slope, because we don't like to write it so much, is they use the letter M to represent slope. So instead of writing slope, I can write my M will equal 3 over 20. Now a slope has another part to it. A slope can either be positive. In this case, you see my airplane is going up. When it's going up like this, and we start at the left-hand side, when it goes up, my slope, I'm going to write it in M, is going to be positive. Now let's look over here. Bad things happen when an airplane starts heading down to the ground. Bad things, negative things. So when we start up here and we go this way and we're heading down, our slope in this case is not going to be positive, it's going to be negative. Okay, so when you're looking to see if your slope is positive or negative, here's what you do. You start on the left-hand side of your incline, and you say, if I put a plane, usually I use a car, but a plane's okay, and it starts heading down, it's going to eventually crash. That's a negative thing. So if it's going down, my slope will be negative. Okay, so it's negative here. And if it's going up to heaven, that's a good thing because an airplane's not going to crash. If it's heading up, it's staying away from the ground. So my slope here will be positive. Okay, so those are the two things that we're going to have to remember. Okay, how do we figure out our slope is positive or negative? All right, now, because we have rise over run, if we use a Cartesian coordinate system, okay, if we graph this on a Cartesian coordinate system, and let's just see how that looks. Instead of saying rise over run, we say the distance that it goes in the y direction over the distance that it goes in the x direction. All right, so let's see. What is he saying now? Let's erase some of this stuff so we have plenty of room. And I think we're going to try to get away from airplanes. Okay. Hey, let's look at a Cartesian coordinate system. Here we go. points on here. It doesn't matter what 2 points I choose. Okay, here's 1, 2, 3, 4. -3, -4, 1, 2, 3, and 4, and -1, -2, -3, and -4. All right, let's just pick 2 points. Let's pick 2, 2. We'll put a point here at 2, 2, and I'll label it as 2, 2. And let's pick a point way down here. Let's say -3, 4. Okay, so we put a point right here, -3 and 4. And we draw our lines together. Here we go. We connect our dots. All right, now the very first thing that we're going to have to do is we're going to have to determine what's the side of my slope. Okay, as we talked about before, I'm going to use a car instead of an airplane. I'm going to come over here and I'm going to put a little car over here. Okay, here's its headlights. And if my car goes up a hill, if it's going up, it's going to be positive. I always put it on the very left-hand side. Some of my students before have put the car over here, and they say, well, Mr. Kiger, it's going downhill, so my slope is negative. No, we always have to make sure that we put our little car over here on the very end of the left side. And because he's going up a hill, okay, I know before I even start that my slope is going to be positive. Okay? Now we've already learned that the slope of anything, the slope, is equal to the rise over the run. All right, let's see if we can calculate the rise over the run here. All right, to do this, what we want to do is we want to make a right triangle out of this line. And okay, I can do this. I'm going to go shoot right through this 4 here. And I'm going to stop at 2. And I'm going to come down like this. Bing, 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 bing. Now, as you can see, I have 2 sides. I have my horizontal and I have my vertical. This is my rise and this is my run. So what I'm going to actually do now is I'm going to calculate the distance. So if I start here at 2, I don't count 2, but I start at 2 and I say 1, 2, 3, 4, 5, 6. I say that my rise is 6 units. Okay, and I'll put a U here for 6 units. Then down here I want to go ahead and say how far is my run? Okay, my run is 1, 2, 3, 4, 5. It's 5 units. So according to my slope formula, the slope of the line that I just put down there, slope is going to equal, it's a positive, because we calculated that before, a positive, rise is 6 over 5. Now, normally you leave it as a fraction, and normally you check to see if you can reduce it. If you can, you use it in a reduced state. If not, you leave it the way it is. So the slope of this line is 6 over 5. Okay. Now, we can do the same exact thing if the line was going the other way. Okay, let's just say if we had a negative slope, how would that look? Okay. Now, let's put 2 more points here. We use a little red to contrast it. All right, let's say we have -3, 2, which is right here, big dot there. And let's just say that we had 3, 0, which is right here. All right, let's make our line. We're going to make our line like this. Ooh, yeah. Okay. Now, the question that we first should ask ourselves, is our slope going to be positive or negative? And how do we figure it out? We go to the left-hand side and we put our car here. Here's our car. And this guy is not going up a hill, but he's going down a hill. Down, just like the airplane, down is bad, down is negative. So in this case, we're going to have a negative slope. Okay, so right away I'm going to come over here and write my slope, which I can write as m. My slope is going to be negative, and I don't know what my slope is yet, but I'm going to come back here and I'm going to make a right triangle out of it. Okay, so here's how I like to make my right triangle. I come down to the 3, and I go across this way. Now we already know that the slope is my rise. How high does it go up or down? Over the run. Well, in this case, we're going to start here and we're going to say 1, 2, because that's exactly where the rise is. So it's 2 units. And here it's going to be 1, 2, 3, 4, 5, 6 units down here. Okay, so in this case, my slope is going to turn into rise is 2 over 6, but we have to reduce it. So the slope is actually going to be negative 1 over 3. And that's the slope of this line right here. Okay, now we've got some very very special case to calculate the slope without using the graph here and counting down the rise over the run. Okay, and that's what we call the slope formula. Okay, now you're all going to have to memorize this because we're going to use it time in and time out. Okay, now the slope formula says this. We're going to write m for slope. M equals, now this deals mainly when you have Cartesian coordinate system and you're going to have points. Okay, you're going to have 2 different points. For example, this point here is negative 3, 2, so I'm going to write this down. Negative 3, 2, and down here I have 3, 0. Okay, so I have 2 points, and I'm going to bring them over here in a second. But what we do is to find the slope formula says is this, y2, little subscript here, minus y1, and I'll show you how that works, over x2 minus x1. Ladies and gentlemen, it doesn't matter which point you put first or second, you're still going to get the correct slope. I'm going to take my 2 points, and I'm going to say negative 3, 2, and 3, 0, 3, 0. And we can name this x1, y1. Okay, we're going to name this x2 and y2. And you could switch them around. If you don't like them that way, you can write 3, 0 this way. And put this guy over here, negative 3, 2. And we could call this guy x1, y1, x2, y2. Now all we're going to do to find the slope is we're going to find the...
I can't mix the x1s and the y2s though, right? I have to have x1 with y1 and x2 with y2.
That's right.
Okay.
So you have y2 minus y1. This is the equation we're going to have. And what we're going to do is we're going to get the information from our points. I'm going to take the first point and we're going to work it, and then we'll see if we get the same answer. We should if we work it with the second one, because it doesn't matter what arrangement you put your points in, you will get the right slope. So you see that over here is my y2. It corresponds to this, and this is my y1. This is my x2 and x1. Normally, I don't really write this down because what I usually do is I say, oh, I know this is y. I take this and I subtract it from this. So let's try that. 0 minus 2 over, and then 3 minus a minus 3. So don't get caught up. 3, you have the 3 here, that goes there, but then you have to subtract minus, and the number is minus 3. So 3 minus a minus 3 actually turns out to be what? 6. So what you're going to get is negative 2 over 6, and you have to reduce it, and you get negative 1 over 3. And you'll see, that's my slope. That slope is the same slope as we got over here when we calculated it by counting the distances. Okay? Now, all right, I got this, I use this here, but will I get the same slope if I take my points and I flip them around? The answer is yes, but let's just look at it. All right, the top one is going to be 2 minus 0, y, y2 minus y1, and then negative 3 minus 3. Okay, so I'm going to get 2 over negative 6, which is negative 1 over 3. Bravo, bravo! We got the same slope this way, we got the same slope this way, and when we counted the units, the rise over the run, we got the same slope this way. Okay, 9 times out of 10, you'll be using the slope formula to figure out your slope. Okay, now, there's 2 more things that you need to know about slope. There's 2 special cases. Okay, and that's a vertical line and a horizontal line. So let's look at a vertical line first. Okay. Let's just say I have this. And we'll show the reason. Okay. -2. Okay. Okay, what if I had a vertical line? Let's just say this line is passing through 2. Okay? And vertical just means that it's up and down, this way. Okay, how would I figure the slope of a vertical line? Well, the first thing we need to do is we need to get 2 points. All right, we can get 2 points. Here's a 2 and a 2, and if I put it here, I'd have 2, 2. And let's get a point down here. How about 2, negative 3? 2, negative 3. Okay, this is quite easy because we know what the slope formula is. Slope formula, it says this. The slope is y2 minus y1 over x2 minus x1. And we have 2 points. We have 2, 2, and we have 2 minus 3. Now, as you saw before, it doesn't matter. We're going to get the same slope whether it's this first or that first. So we're just going to do it 1 time instead of 2. Okay, so this is my y2, and this is my y1. So negative 3 minus a 2. And then here I'm going to have 2 minus 2. Oh, I see a problem already. Okay, does anybody see the same problem I see? Yes. We've learned previously that any division by 0 here is undefined. Okay, can't happen. Impossible. So what they say when you have a vertical line, they say that the slope, that there is no slope. NO, there's no slope of a vertical line. Okay? And that's the reason. Now, what I usually do is I just have kind of memorized that over the years, that I know I don't have to go through this procedure, that I know that a vertical line up and down has no slope. Now, what if we had a line that passed through this way?
Is that the same as 0?
No. No. No slope is not the same as 0. A 0 slope is something different. We're going to touch on that. No slope means that you can't figure it out. Impossible. So your answer for this guy is this line has no slope. And it's the only line in the universe here that you're going to find that has no slope. Every other line will have something. Now we're going to show you the other type of line. It does have a slope, but the slope's a little different than you may think. Let's just say that we have a line going through 3. Okay, it's a horizontal line. Okay, if you think about it for a minute, without doing the calculations, let's just say you put a skateboard here. Is it going to go anywhere? It's going to sit there, right? It's not going to go down, it's not going to go up, it's going to just sit there. So let's see what the slope is. If I was going to make a guess on the slope of this line, I'd say the line has 0 slope. 0 slope, and then as my line either moves up or down, it would have plus going up this way or negative. But let's just check it out. We'll do the same thing we did before. We'll take 2 points. Okay, I'll take this point, which is 2, 3. And let's just pick this point, 3, 3. Negative 3, 3, which is a point right here. Okay, we'll come right back over here, and we'll use the same exact formula. Okay, so in this case, I'm going to have negative 3, 3 here, and I'm going to have 2, 3. Now by now, you should know that this is x1 and y1. This is x2 and y2. And we're going to subtract y2 and y1. So I'm going to have 3 minus 3 over, and then 2 minus a minus 3. Why is that minus 3? Because I have a positive 2 here, and the name of this is negative 3, but I still have to subtract it. Just because it has a negative number doesn't mean you can forget about the subtraction. So it's going to be 2 minus a minus 3. And our answer over here is going to be 0 over 5. Okay, in this case, if we have the denominator as a number and a 0 on top, our answer is going to turn out to be 0. So in this case, my slope will equal 0. And those are the 2 cases of slope.